Okay, welcome back. So now we're going to look at a very simple macroeconomic model. Okay, so most of the stuff in this model, you know it. But now we're gonna show how we can express these relationships of a simple macroeconomic model using a social accounting matrix. Okay, so now we're gonna see some equations. We are seeing some equations. The first equation is defining gross domestic product by making it equal to total investment, total spending, right? So there is private consumption spending, CD, consumption demand, and then you have investment, then you have government spending, E, then you have net exports, right? X minus M. So X is the total volume of exports, M is the total volume of imports. So you have the trade balance. Now in equilibrium, of course, you know that this must be equal to income, right? And here W is denoting the total payments received by the workers, okay? K denotes the total payments received by the capital owners. So in this economy, we have two factors, basically, labor and capital. So a portion of the GDP, of course, is paid to labor services as W. Another portion is paid to capital services, denoted by K. And then we have indirect taxes, right? Because taxes are part of this income streams. Then this income, this after tax income, so that if you separate out the indirect taxes, this must be equal to consumption, saving, and the direct taxes, right? So R2 here is direct taxes. So it is, for instance, an income tax, right? So you obtain this income. Out of this, you pay a direct tax. So in this version, there is no transfer. Okay, there is no transfer spending by the government. So in the fourth equation, we define the budget, right? So budget balance is D. So it is taxes minus spending. So if it is positive, the government has a budget surplus. If it is negative, the government has a budget deficit. Okay. And finally, we have the trade balance as well, right? So X minus M is net exports. We denote it by F. So if it is negative, we have a trade deficit. If it is positive, we have a trade surplus. Okay. Now, as you see, it is a very simple macroeconomic model. The ones you always study in your macro classes. Only this time we're going to be more specific about taxes, and we're going to be more specific about different components such as government and external sector. Okay, it's the trade sector basically. Now we want to write a SAM, right? So in the SAM, we have, of course, different accounts, right? So we will have firms, okay? We will have, let me look at my notes. So we will have firms or production. So let me use the correct wording here. So we will have production, we will have labor, capital, okay, consumers, government. So we will have in between, okay, so we will have the capital account. Be careful, this economy is open, right? So we will have a capital account here, then we will have the government, okay, we will have the government, and then we will have the current account, basically trade. Your textbook calls this account the external sector. Okay. So if you remember, so this is 1, 2, 3, 4, 5, 6, 7. Is that correct? 7. All right. So I have 1, 2, 3, 4, 5, 6, 7. Let me use a better spacing here. So 2, 3, 4, 5, 6, and 7. Okay. Now remember, we have incomes in rows, right? And expenditures in columns. You remember that? Incomes in rows and expenditures in columns. So now we're going to do exactly that by using our equations, because those equations must be true, right? So let me start from the simplest account. I will denote the production relationship, production account, as A. Now, what is this A? This A is to represent the input-output relationship within the production sector, right? So in that first column and first row, we will have many different sectors, many different firms producing stuff for us. That production becomes, of course, GDP at the end, right? So within that, firms can have input-output relationships. For this reason, we denote it by simply A, all right? And that production is there, all right? Now, another simple account is the external sector. In the external sector, we use this formulation. So income is so import is kind of accounted as income for this sector, right? Because the external sector imports goods and services from the outside world or the rest of the world, all right? Then this trade balance, of course, must appear here, right? In the capital account. Remember the balance of payment system, right? So if in the capital account, if you are giving a trade deficit, that must appear in this way. So remember, in the meantime, expenditures and so incomes and expenditures must be equal, right? So if you look at the seventh account, X minus F must be equal to M, or X minus M will be equal to net exports. Okay, so this is our last equation. So that equation must be satisfied, but the trade deficit has to appear as an income account in the capital account, right? So this is the balance of payments relationship between capital account and the external sector, because external sector is basically current account. Okay. Now, let's imagine what are the income. So let's look at the second row. Okay, labor. So labor services have income, which is equal to W, right? And it is originating from where? It is originating from the production sector, right? So we have W here. Why? Because again, this is as we say before in the earliest example of a SEM, this is the income for the labor services, and that is an expenditure for the production sector, right? So firms in the economy pay for the labor services. Similarly, firms in the economy pay for capital services. Okay, and that's there. Now look at consumers. So we assume, of course, consumers are the owners of these labor and capital services. So they supply labor, they supply capital, right? So consumers' income are going to be originating from the labor account and the capital account, right? So we have something like this. So from the labor account, right, from the labor account, the consumer obtains some income, which is labor income, and from the capital services, the consumers obtain capital income. So maybe we can call them labor services and capital services. Okay. So be careful. This capital account is in the sense of balance of payments account. Okay. Now, consumers, of course, also pay indirect taxes, etc. Right? So where are those things? So you should be careful with that as well. All right. So we are coming to that. But there is no other income, right, for consumers. Now, in the capital account, what do we have? You must remember this. Or let's look at the government first. So government is obtaining taxes, right? Again, the production sector pays these taxes, and then consumers pay the income taxes, right? Because they obtain income, right? So let me double check. Yes. So what is going on here? Again, so here we basically make the firms pay the value-added tax, right? As in, so in reality, of course, this depends on the country's specific tax code. But here in this simple example, so it is a very simple indirect tax. So it is paid by the firms to the government when there's a purchase, basically, right? And then there's this income tax, R2. So this is the direct tax. And the direct tax is paid by the consumer. Look at this, consumer is paying that, right? So this becomes another source of revenue for the government. Now, government is making a spending, right? Government spending is there. Now, government spending is becoming, so this is 6, government account. So government spending is becoming an income source for the production. So similarly, consumers, account 4, make consumption demand. All right. Now, then the investment in the economy will, of course, appear here, right? Because it is the capital account. Remember, you know, balance of payments. We have the current account, basically X minus M, and then we have the capital account, right? Basically I minus S or something like that. Okay. So if you, so you have, if you once again think about leakages and injections, so you have S, so you have saving plus tax plus import being equal to investment plus government spending plus exports. Okay, so this is the simple macroeconomic identity. All right, so this must be true for any macroeconomy. All right. So then again, in the capital account we have I. Now, obviously, the deficit must be somewhere here, right? The government deficit. So where is it? The government deficit should appear where? If you look at this identity, you're gonna understand it. So let me simplify the stuff for you. So this is 0, this is 0. These are all zeros, right? There's no other account that pays for labor or capital. Only the production sector pays for labor and capital, right? And consumers, they do not give anything to they do not obtain anything from the production sector because they obtain from labor services and capital services their income, and then they also have 0 here. So in the capital account, we're going to discuss that. I'm not putting anything there. In the external sector, we have nothing more, right? So all of these are 0, because in the external sector, from the production, there is import, and to the production, we have the exports. Then the capital account. So if you use this, you're going to realize saving and deficit must be like this, okay? Because we have what? Now the row sums must be equal to column sums, right? So if you look at, let me open some space here. So if you be very careful, you realize what? Look at the capital account. In the capital account, you have okay. So you have saving plus deficit, or so this is basically budget, minus F equals investment. In other words, you can write it in this way. So you have saving here, right? Plus this is the budget. So this is tax minus government spending, right? And this is minus F. Minus F means M minus X, right? So like this, and you have I. Now, if you put government spending and exports to the other side, you're going to arrive at this simple macroeconomic identity. Okay, because in an open economy, the current account and capital account and the government budget is related in this way, as you know. Okay. So that's it. That's your simple macroeconomic SEM. Okay. And it tells you, now, if you think about it, suppose that you have data, you have the data for a particular economy at a particular year, right? So in a particular economy, in a particular year, you have the production data, you have the spending data, you have income data, and then within the production sector, so imagine this is your first row and first column, right? The first row and first column will itself have many different rows and many different columns, right? So suppose that in this economy, there are six sectors, okay? Then you have sector A, sector B, sector C, for instance, sector D, sector E, sector F. You have A, B, C, D, E, F. So these could be different sectors: agriculture, mining, industry, construction, services, etc. Right? Or you can have different firms. You can have many different rows, many different columns, obviously. And then input-output relationships will, of course, exist between these sectors. So then you can also imagine different production factors such as land, energy, etc. You can expand, for instance, consumers, right? Consumers with different ages, different regions, different occupations. As long as you have the data, you can do many stuff with these SAMs, all right? And then, as I will discuss next, we're going to use such data, such social accounting matrix data, to calibrate our models. All right? So now, if you have any questions, now it's time you can ask, or I will continue with more stuff. So don't forget, incomes in rows, expenditures in columns. So consumers, for instance, obtain income from labor services, which is W, and from capital services, which is K. Now that income must be equal to, for consumers, for instance, that income must be equal to spending. So what are the spending components? Well, there's consumption demand, then there is saving that is not spent, of course, and then there is income tax. Okay? So income equals consumption and saving plus tax, right? For another account, look at this. Government account. So government's revenues, so these are government's incomes basically, right? Spend on what? Spend on two things. Either there's government spending or the budget balance. So if D is positive, then it is a surplus, right? Because D plus E must be equal to R1 plus R2. So all of these incomes and rows must sum to equal numbers, obviously. Okay. All right. So you want to ask anything about all this? Okay. So then let me show you very briefly what calibration is and how we will use such data. Okay. So let me show you something about first econometrics, okay, because they are slightly related. Now in econometrics, in the simple model, you have something like this, right? Remember this model? So this is some dependent variable y, and this is the vector. So this is the matrix of independent variables x. This is the vector of parameters of the model or coefficients, and this is the error term, right? So if you have your sample, right? So you have some number. So this is your sample size. It's your sample size. So you have a vector here, a matrix here, the parameter vector here, and the error term as well, right? And then you define your errors in this way. Okay, so this is now m by 1. And if you calculate this, so what is this? So this is the transpose, right? So
Hocam ekranı biz şu an göremiyoruz ama.
oh, okay, sorry. I'm constantly forgetting this. So there's something in the chat, possibly. Okay. Okay, sorry about that. So this is your, simple OLS regression, right? Dependent variable, independent variables, coefficient vector, and your error term. So if you take the transpose, so you have this, right? So this is, in the meantime, of course, equal to this. So if you have observations, for each observation, you have yi minus, beta 0 minus beta 1 x1i, beta 2 x2i, right? Beta k xki, or something like that, right? And of course, this is squared. So what you do, of course, then you minimize by choosing beta, you minimize this animal. So this is your ordinary least squares. Okay, so you find out of this problem, you find beta hat, right? Now, in the calibration, we do something similar but different. How similar? Well, we use a model. So here, if I write this once again, here, this is your model, right? This is your model, and this is your data, basically, because you want to use this model to explain data, okay? And then you use a device like this, which is basically econometric estimation, to learn the parameters. So what you are doing here, you are using the data and you are using the model to learn about beta, okay? Now in the calibration, that part is similar, okay? Because you're gonna use some data, SAM, and the model, okay? And you learn something about your parameters, okay? So that part is the same. What is different is that we're gonna use different types of algorithms, not like, I mean, some of these algorithms resemble econometrics, some econometric methods, but usually we don't have a well-defined, useful sample to run econometric estimations, okay? So in that sense, it will not be stochastic and it will be deterministic, all right? So most of the calibration stuff you will see will be a deterministic exercise, not stochastic. Because here, of course, you have an error term, okay? In the calibration exercise, most of the time you don't know the error terms, okay? You don't know your errors because it is not defined, okay? So the idea is, again, using the real world data for a particular economy at a particular time, and in the meantime using the model to learn something about the parameters of the model. It's exactly in this sense, it is exactly as if we are doing some econometric estimation. But it is not entirely an econometric estimation, not specifically because we don't have errors. All right? Why? Because most of the time we don't have a very well-defined sample. We only have 1 year of data. Sometimes some data is missing. for some consumers, we don't have enough data. For some firms, we don't observe their profit, etc., etc., etc. Okay, because of basically data limitations, then our exercises should be different from what we do, as usual in econometric estimation. But the idea is again to learn something about the real world. I mean, to use something about the real world and to make a match. All right, because what you do here is a match, right? You are finding betas that create a good match between your model and your data. All right. So once again, we're gonna exploit that. If you want to, so suppose that you have SAM in the data. Okay, we can be more specific, and that SAM data comes with rows and columns. Okay, so when I write SAM data ij, what I mean the ith row and jth column. Okay, now this is just data, numbers, right? This is just data, numbers. And then you also have the theoretical SAM. Okay, you also have a theoretical SAM, and that theoretical SAM, maybe I can do this. This is not very good notation because I got to define this as a function. So when I write this, it is ij, but now the model SAM depends on the parameters. So alpha is your vector of parameters. Right? So so your social accounting matrix, in theory, once you solve the model, right? You know, for instance, consumption will be a function of prices, right? For instance, you know, the use of a factor will be a function of prices and output, or something like that, right? So you know these solutions. So then your SAM, your theoretical SAM will be a function of parameters. Okay, so we have less than a minute. We're gonna continue from where we are right now. It is 10:35. Let's meet at 10:50. Okay. Let's meet at 10:50. I will see you at 10:50.